Today, I have the privilege to introduce our speaker, Scott Bradner. The title of his presentation is Death of the Internet, GIF at 11.
All right, so I'm going to talk about death of the Internet. This is a phrase that came up in the early 80s on Usenet. It usually showed up as death of the net, GIF at 11, towards the end of a spirited discussion on something when somebody said something stupid like, let's charge everybody for email in order to get rid of spam. As one knows, that doesn't work. So, but what internet are we talking about here? I'm not talking about local connectivity. I'm not talking about your family saying the internet's down when somebody tripped over the power cord for the Wi-Fi router. I'm talking about the internet as the conceptual thing that provides connectivity around the world. And we're talking about people saying that that doesn't work, or that's going to get replaced, or that's going to fail next week. And when I say death, what do I mean? I mean predicted significant outage. Somebody says that the network will collapse and just go away, or that it'll be entirely useless. The internet itself is useless, or it doesn't work. And you'll see that most of these cases are this, that they're going to replace it. They're going to replace this internet thing we've got with something that works. The net has died many times. As a matter of fact, it started dead, according to the mindset of a number of folks. Generally, when somebody declares that the net is dead, there's somebody there to transform it, but not necessarily to rescue it. I'll review a few of these predicted deaths. There are certainly many. They're going on all the time. And a few of the would-be net killers. Obviously, none of the deaths took. To quote Elliot Norris, writing about fallen trees in the Olympic National Forest, the net has had a lively death indeed. You'll see down in the lower right-hand corner of these slides that I've said the categories of who's making these predictions or where this is coming from. We've got the upper left-hand corner here as bellheads, the telephone world. Next to that is the news media, where they're, let's say, challenged understanding of technology. And Evie Nemeth's 9-layer OSI model with a political layer, and there's a lot of politics going on here. And finally, the business, and Wall Street going nuts over something. So let's start with the beginning. Paul Barron came up with a concept of packet switching. He called it message blocks, but it was packet switching that Donald Davies renamed it. But Donald Davies and others have all said that Paul Barron did this. Cheap, reliable, fast, all kinds of stuff for voice and data, not just for voice, not just for data. He went and presented his ideas to AT&T back in the early 90s, in the early 60s, sorry. And he was told, quote, "Son, this is how a telephone works." And they led him carefully through how telephones works. And as far as AT&T was concerned, there was no conceivable way that packet networking could work. So the net was dead before it even started. But ARPA persisted, and yes, Donald Davies and Larry Roberts and many others were key to doing this. And this was the first case of telephone mentality saying that the internet doesn't work or can't work. The telephone vehicle came along with X25 as the data solution, connecting all your computers together. It was a primary way of doing data connectivity for quite a while in parts of the world. Very expensive because they charged per block, per byte, or per unit of transfer. And that can get very expensive. But that's one of the features of the telephone proposals is you have to pay for a drink for them. But this X25 turned out to be a moderately okay transport for the internet, other than the cost. The actual functions were okay. I used it under ISDN at Harvard for a while, but that way we were getting flat rate there, so we didn't have to do the huge prices. A major claim of the internet, as is the TCP/IP internet being useless and going to go away, was the OSI gossip IPv7 mix-up. The governments got together through the ITU and came up with this OSI concept, actually not the ITU, ISO, came up with the concept of the OSI Protocol Standards, Open Interconnect Standards. Vastly complicated, complicated enough that you couldn't actually implement the whole thing, and instead you would do a profile, which was a subset. On the left-hand side here is a set of the standards that go into the OSI protocol suite. But this was the future. It was not just the future because it was better, because it wasn't, but it was the future because the government said it was. It was mandated. You had to provide the OSI protocol suite when selling products to the government, to the U.S. government and to many other governments around the world. So this was a political case where the governments had decided that because this standard was created by a recognized international standards body, then it must be the right thing. Even the IETF was on board for this. The IETF had an OSI transition area at the time, and the IAB came up with IPv7, which was just using OSI. That led to the IAB's ouster as the IETF's standards approval body, and OSI went away. Finally died in the mid-1990s when the U.S. government decided that the parts of the government could buy products that actually worked rather than products that they were told they had to buy. Then there was ISDN, another telephone mythology. ISDN was the future, and it was all that you needed. It connected voice, and it connected terminals to data, to computers. When MIT went to buy a 5E switch, the salesperson said that the 5E came along with ISDN, and ISDN could replace all those Ethernets that MIT was putting in. 64 kilobits to the desktop was plenty, and if you had a server, well, then you could use ISDN primary rate at 1.5 megabits per second. We had ISDN set up here at Harvard using the Centrex service out of the local telephone company. It worked okay. It was expensive and complicated, and it was very, very difficult to get technicians to understand how to actually, telephone company technicians to understand how to actually make it work. But again, it was the future. It was going to replace all of these silly things like Ethernets. We had a self-inflicted wound in the IETF in the early 1990s. In 1990, Vancouver IETF meeting in 1990, Frank Solinsky projected that we're going to run out of Class B IP addresses, address blocks in the middle of 1994. The press picked this up, and so did Wall Street. And it was decided by Wall Street that nobody should invest in any internet protocol-based service because the internet was running out of addresses and would just fade away. Novell proposed using IPX instead because it had 48-bit addresses instead of 32-bit addresses. They failed to mention that those 48-bit addresses were semi-randomly assigned, and it would do wonders to the routing table to adopt it as the protocol. IBM offered SNA, but SNA, while it appeared to have larger addresses, really didn't, because SNA addresses were EBCDIC encoded characters. Quite quickly, the IETF recovered from this, proposed NATs and CIDR addressing, and everything was fine. But it took many months, maybe even a year, for Wall Street to come back and start investing in IP-based things again. And of course, there's ATM. ATM was going to replace everything. Particularly, it was going to replace IP itself and most of TCP, because it had routing, it had flow control, it had guaranteed quality of service, and it was going to do everything. I was admonished by the chair of the ATM forum when the IETF came up with an IP next generation that didn't assume that it was running over and as part of ATM. I didn't think that we were going to get ATM to the center of Africa or even the center of Newark all that quickly. But they were absolutely convinced, the telephone companies were absolutely convinced, and billions of dollars were spent on ATM service. The idea was you'd have an ATM pipe into your residence or into your business, and you get voice, video, and data over that. And again, this is the telephone company providing you the entire service. There's no reason for you to put in your own network. And this internet thing would go away because it would just globally interconnected ATM networks. And the phone company would provide it for you, of course. 1995, July 1995, Time magazine published a cover story which said, in essence, that 80% of the internet was porn. Now, this was a breathtakingly poor piece of research. It showed that somebody who was looking at the porn news groups in Usenet and discovered that the porn news groups in Usenet contained porn, such a concept. And in particular, 80% of the material on the porn news groups in Usenet was porn. To me, that's, what was the other 20%? Somebody's short-circuiting me. We're not getting my money's worth. But this was a big deal. The press went nuts over it. Congress went nuts. Politicians all over the world went nuts because you can't possibly use this internet thing for anything where a kid might be involved. You can't bring it into schools. You can't bring it into homes. Even businesses are chancy, not because there's kids in the businesses, but because somebody might say something on the net that was offensive to a kid someplace. Then so the internet was not going to be useful because it was all full of porn, and therefore it was going to go away. Bob Metcalfe, who should have known better, he understood congestion when he did Ethernet, but he projected that the internet was going to have gigalapses, huge collapses like worldwide traffic jams on a highway system. And it didn't make any sense at all. He and I had back-to-back columns in Network World and a number of other publications where he was saying that the world would end, the internet would collapse, and I was saying that he was looking at the world through doom-colored glasses. He said he would eat his column if he was proved wrong. He ate his column. But the press believed what he was saying because they didn't really understand how this thing worked. Partially as a result of the Time magazine cover story, the U.S. Congress passed the Communications Decency Act in 1996, which made it illegal for you to send anything on the internet that a kid anywhere in the world under 18 shouldn't see. So it made it safe for kids by making it impossible for anybody but kids to use it. This ran into the First Amendment in the U.S. I testified in federal court on this and said that the strength of the internet was the chaos of unfettered innovation. And the judge quoted that in his final judgment to say that it was that the CDA was entirely unconstitutional by saying that the chaos of unfettered speech was critical in the U.S. Note one part of the Communications Decency Act did survive, which is Section 230, which some people have said invented the internet. I assume that you know what that is. If not, go find your local search engine to figure it out. Of course, the CDA was passed in an election year, and in an election year, no one's going to vote in favor of child porn. So it was a foregone conclusion it was going to be passed, and it was only the courts that rescued us. I first heard about 3G in Taiwan from a Bellcore a longtime Bellcore employee who said 3G cellular phones would replace all networks, all Ethernets, all Wi-Fi. Wi-Fi had only just come into being at that point because this, again, the telephone company is going to provide the data service to you, to every device, and the phone company would provide that for you. The Ethernet jack in the wall would go away because every device would have its own 3G wireless connectivity. Same thing, of course, was said about 4G. It's going to connect everything together, and the phone company will provide the service, and you wouldn't have to be running your own network at home or at the business. Needless to say, they didn't quite succeed in that fashion. Another person who should have known better is Larry Roberts. He was one of the people that actually built the original ARPANET, and he understood how things worked. But he decided that he concluded that the net was beginning to get so congested that it was completely going to fail. And the only way to succeed in this was to go to flow-based networking, so that all the core routers, all the backbone routers, would be replaced with routers that, for example, his company, Caspian Networks, built, which would allocate capacity based on the original link speed. Strangely enough, that didn't happen. This was a business play. It was a lot of money went into it, including some of mine, through a venture capital firm that I had invested in. And of course, it went away. Hundreds of millions of dollars went away. But Larry had a great slogan: "The internet's broken. I should know I designed it." Or maybe they should admit he designed it wrong. Well, he didn't. Then in the early 2000s, ITU decided that they were going to fix the internet by replacing it entirely. Replace it with something that they call the next generation network. They didn't actually think that the internet would go right away. So they included in this diagram in the lower right-hand corner as that's the internet. And everything would be gatewayed to and from the core network would be this next generation network. If you were going to be doing voice, you would always use the next generation network because you get guarantees, which you don't get with the internet. People would spend extra money in order to get this connectivity, this guaranteed service. I was at a panel in Geneva at the ITU where they were discussing what standards were needed in order to implement the next generation internet, the next generation network. And I said I didn't think there were any that were really needed. This internet thing seemed to work pretty good. And in particular, the business model of charging people more for better connectivity, I didn't think the internet was reliably crappy enough to support that business model. They disagreed. And when I said that I didn't think there was additional standards needed, the person who came up after me from British Telecom said that we were missing the TCP settlement protocol, which allowed them to send bills for individual TCP sessions. Then we've got this whole thing about in-network neutrality. A lot of us liberal ends, let's say, were convinced that the carriers were going to come to the conclusion that they owned the network and that they could control it and control who did what on it. And they tried. A few telephone companies did try and do that. They blocked VPNs or they blocked voice over IP. The FCC, under Michael Powell originally, but then under successive leaders, tried to come up with a way to say to telephone companies that they should just be moving bits. They shouldn't be actually controlling what was on their networks. They should take the telephone network, post Carter phone, as an example and just provide communications for anybody who wanted it. But the courts kept shooting them down. Finally, the FCC in 2015 followed the direction of the courts and said that who said the only way that the FCC could regulate ISPs was to reclassify them as Title II under the Communications Act as in common carriers. So the FCC did that. It survived a court challenge. It didn't survive a change of administrations. When a new president came in with a new party and a new FCC chair, they undid that setting. A number of us thought that Title II was an awful solution, but it was the only solution the courts would permit the FCC to do. And the FCC said they wouldn't put the thousands of individual regulations on. They just put in the ones that are necessary to ensure that carriers stayed out of the way. When the FCC undid this, they called it restoring internet freedom. Of course, the only internet freedom they restored was the freedom of carriers to control what you do. Now a big thing is 5G. The same thing. It's going to replace everything. You get rid of all your Ethernets and Wi-Fi and everything else. It'll all be 5G, gazillion, blindingly fast, instant violating the speed of light speed, all kinds of stuff. And it's, again, the telephone company is going to provide this for you. And something going on right now is what has been called the new IP. It's an effort by Huawei and the Chinese government, or the Chinese government through Huawei, to define a new transport layer for the internet. They tried initially at the IETF, and the IETF basically said, nah, we don't really think that's needed. So now it's being worked on at the ITU. A key feature of this is this new IP is that it's flow-based, but that flows are not permitted to be carried until the flow is tied to an individual human being. So 100% identification of all communications. And it's going on right now. The ITU will probably spend another decade working on this like they did NGN, and we'll get much of the same result out of it, nothing. And then more recently, the news media has all gone bonkers over COVID-19 and the effect on the internet. The stories are that Netflix is reducing the quality of their image in Europe, etc. But the reports I've seen is that the peak usage of the net in the US, with all this stay-at-home efforts, hasn't really changed. It's just spread. Instead of being at after dinner, it's all day long now. So that the networks haven't had to be strengthened and built up because they already were able to support that peak load. But the news media doesn't quite get that and is all a titter about it. So what's the root cause for all of these? There's only a few of the many that are out there. What's the root cause? Well, first of all, the telephone company and the people that came out of Bellcore and the like don't believe that packet-based networking actually works. They would need to have circuits in their mind in order to get guaranteed quality of service. Enough capacity is not enough to provide what they believe they needed. So just like bumblebees can't fly, the internet can't work by definition. The politicians want to censor, and the most recent, certainly the new IP work out of China and Huawei is a censorship play. They want to be able to control what people do on the network. Money, Roberts and the Caspian networks are trying to make money. And telephone companies trying to make money too. So the telephone issues are a combination of they don't believe that packet-based networking works, and that they want to be in charge and make money and be the place that makes money. They moved from an environment where they were king. They were making billions of dollars, trillions of dollars on voice services, and that's mostly gone away, and they want to get back into the game. And this politicians pontificating, that's what got us to the CDA, and that's what will probably be a major factor in the new IP, is that the politicians will say we need to do this in order to be able to censor and control and monitor our citizens. And finally, the press. The press really doesn't have the faintest clue in general of how this network works. And so they, like being an expert in politics or liposuction, just by throwing a dart in the morning, they're trying to understand and trying to tell us about the net, and they're failing dramatically. Oops. So what do we got? What we have is the network that's the mother of revolution, that didn't fail, that didn't die. We have had a number of cases where people thought it was going to die. I've just shown you a few, but Victor Hugo and the Hunchback of Notre Dame described the printing press in the way that the net has actually acted. It is it's the parent revolution. It's the revolution that revolutions are born from. The network itself is not the revolution. It's what it's done to business. It's what it's done to society. It's what it's done around the world in spite of great odds and many people saying it wasn't going to make it. It still did. And I think that's a good ending.
Thank you very much, Scott. Thank you for your contribution. It was nice of you to do this for us. We appreciate it very much. We're now going to go into the Q&A session. We have a few that are lined up. And if your question was, who is this person on your screen talking to you, it's the correct answer is Papa Smurf. That's what my niece says anyways. So the first question, Bradner, that we have for you is, what do you believe the biggest mistake we made was, and we being the IETF, IRRs, ICANN, U.S. government, network operators, et cetera, that had been made during the establishment of the internet?
Biggest mistake? I think probably, I don't think we've made a large number of mistakes. We've made some detours, and I talked about that in the presentation. But in the end, the fact that we weren't sure of ourselves and the government wasn't sure of itself meant that we got what we deserved, which is a network that was generative and working and doing all those wonderful things. I don't think that, I think that the obvious thing that governments would have liked to do is to control it, to censor it. And the same thing for telephone companies. They would like to get money out of it. But I don't think that we fumbled through without making big mistakes.
Okay, thank you for that. Next question we have is, do you feel that the Telecom Act from 1996 killed unbundled elements and therefore the CLECs and competition in the last mile? Hasn't that truly killed choice for end users' ability to choose?
Well, it's not. It's certainly a different area than what I talked about in here. But yes, I don't know that it's the Telecom Act per se. It's the interpretation of it by the FCC, and particularly the ability of the carriers to wheedle out of the intent of the sharing requirements, convincing the FCC that new fiber installations were exempt, and then putting all of their telcos into boxes near the home, near the residence, and then running fiber to them. So you couldn't do the unbundling. Canada took a different approach. I don't know what the difference is in terms of availability of competing services, but there certainly is a dearth of that around here. If you're not in an environment that's big enough for cable, you're pretty much sunk. You're on DSL and with a carrier that doesn't particularly care about you.
Okay, thank you for that. The next question we have queued up is, how do you see the impossibilities or possibilities of indefinite growth of internet traffic and connected devices and people on the planet with obviously limited resources and energy?
Well, I don't know how much limited the resources are. We've got fiber growth still going on. We've still got the ability to use the fiber is getting better and better. So I don't know that the physical resources are all that limited. They don't reach where it'd be nice to get them to, which is a lot of the country doesn't have fiber to the residents, doesn't even have fiber to the neighborhood. But so I don't know that we're that limited in resources. We're limited in the desire for the people that bring us the internet to bring us the internet, and not figure out how to convert it into couch potatoes, VCRs, remote controlled VCRs for couch potatoes. So what I really don't think that we're limited in physical resources that much.
Okay, thank you. Next question is, what are the most important next steps of the internet evolution? If not new IP, are there others?
They're certainly not new IP, but the next evolutionary steps. Along the way, we've certainly been amazed, everybody who's been really involved in it, been amazed that protocols and technologies that were designed for 56 kilobit environments, which is the original ARPANET, or environments where a whole country was 64 kilobits, are working in today's multi-terabit environments. But there's no particular reason to think they'll stop continuing to work. The transition to a different system would be a real bummer. I mean, if we go back and look at transitioning to IP from NCP on the ARPANET, That was supposed to happen on January 1st, 1983, with a couple hundred computers. It took 6 months. So there was no flash day. If we tried to do the same thing today, it would take about, using the same ratio, it would take about 4 or 5 times the projected lifetime of the universe to do the conversion. So we're not going to convert away from IP for a very, very long time. We might have, if new IP comes along and gets mandated by governments, which is, of course, their desire, the ITU's desire and Huawei's desire, then there will certainly be difficulties. There are a relatively small number of vendors. There's relatively small number of vendors for the software for smartphones, for mobile devices, for Internet of Things devices, and for computing devices, laptops and desktops. So in theory, one could get rapid deployment of a new protocol. In practice, that's never happened.
Okay, I'll give you one more quick one. We need to wrap it up. This one's kind of related to transition. What lessons should we learn from the slow transition to IPv6?
I think that you transition when you need to transition. We needed to transition in 1983 with IPv4 to get to an internet, not a network of, not a single network, but an internet. One of the things we learned in doing IPv6 was that in very many ways we didn't really need it at the time. The running out of Selinsky's worry about running out of IP addresses was negated by CIDR and by NATS, and has done wonders along that line. But according to Google's mapping, we're at 30% or more. The traffic is V6, and that's mostly because a lot of smartphones run V6. I run V6 at home because Comcast provides it as a default. And so it's taken a long time. I think the biggest issue was that Microsoft didn't care about it and didn't put it into Windows, and therefore there was no demand for it. Apple put it into their products, but who cared? I did, but most people didn't care about Apple at the time. 98% of the network didn't seem to. So if Microsoft doesn't put it there, then companies won't put it in, won't need it. Therefore, the ISPs won't be able to sell it. So they didn't do anything.
Well, I'm afraid we have a lot of more questions queued up, but we just don't have time for them. You give a very popular talk, you're a very popular presenter. We thank you for your very gracious time that you provided to us on behalf of the NANOG community and the PC. Thank you very much, Scott. Just to remind the audience, the BOFs are coming up later today. Please check those out and sign up for a group of interest. And now this concludes our session, and the next session will start momentarily. Thank you very much.